What happens when permafrost melts rapidly across the Arctic? Most people imagine melting ice in softer ground. They think of sinking roads and damaged buildings. They expect slow environmental change in a distant place. It feels far away. It feels manageable. But that's not even the most dangerous part. Permafrost is ground that has remained frozen for thousands of years. It holds soil, ice, and organic matter locked in place. Inside it are the remains of plants and animals that never fully decomposed because of the cold. Bacteria stayed inactive. Carbon stayed trapped. As temperatures rise, the frozen ground begins to thaw. Ice within the soil melts. The structure collapses. The ground softens and shifts. Microbes wake up. They begin breaking down the ancient organic material. This process releases gases. Carbon dioxide is one of them. Methane is another. Methane is far more effective at trapping heat than carbon dioxide. It builds quietly in the atmosphere. It accelerates warming. This creates a feedback loop. Warming melts more permafrost. Melting releases more gas. More gas increases warming. Again, the cycle reinforces itself. In some regions, the gas does not escape slowly. It builds pressure beneath the surface. The ground bulges. Then it ruptures. Explosions form large craters in the Arctic landscape. The Earth opens without warning. Permafrost also traps ancient microorganisms. Some have remained frozen for tens of thousands of years. Bacteria. Viruses. Dormant. When thawing begins, they are exposed again. Most will not survive. Some might. The risk is not constant, but it is real. The environment begins to change first. Frozen soil turns into unstable mud. Forests tilt as roots lose their grip. Lakes appear where land once held firm. Rivers shift direction. Coastlines erode faster. Habitats disappear. Infrastructure fails. Necks, roads crack and sink. Pipelines bend. Buildings collapse as foundations weaken. Entire communities in the Arctic face relocation, not because of a single event, but because the ground beneath them is no longer reliable. Then the atmosphere responds. Greenhouse gases accumulate. Heat becomes harder to regulate. Weather patterns begin to shift. The warming does not pause. It spreads into deeper layers of frozen ground. More carbon is released than expected. The atmosphere thickens with heat-trapping gases. Global temperatures rise beyond earlier predictions. Ice sheets melt faster. Sea levels begin to climb. Coastal cities face increasing pressure. Storm systems grow stronger. Ecosystems fail to adapt in time. Food systems begin to strain. Water cycles become less predictable. Human systems start to destabilize, and the process continues without needing further input. At first, the changes seem local. Remote Arctic regions shift quietly. Within years, measurable increases in methane appear. Within decades, global temperatures reflect the change. Permafrost zones across Siberia, Alaska, and Canada begin to thaw more deeply. By the end of the century, large portions of near-surface permafrost may be gone. Ancient carbon, stored for millennia, enters the atmosphere. Over longer timescales, the impact does not reverse easily. Once released, these gases remain active. They continue influencing climate systems for generations. The Arctic becomes a source of warming. Not a barrier against it. What was once frozen in silence begins to speak, and it does not forget how to change the future. This is not a distant event. This is a process already in motion, and this is only one of the stories shaping our world.